what's the difference between speed and velocity? Okay, so this is how you see it a lot of times. Speed is a scalar. Velocity is a vector. I mean, that's not fully it, okay? Really, there's a problem with definitions here. It depends on how we define this, and we can choose whatever we want. And the other problem is that physicists, this guy, I'm pointing to me right here, and other physicists are lazy, and that sometimes we use these interchangeably, but they're not. The better term is velocity. So let's define velocity. If I have, let's say, a bird flying from here, and it goes up to here, so this is position 1, position 2, and this is the xy axis. Then here's the vector location r1, here's the vector location r2. I can calculate the average velocity as the change in the vector position over the change in time. That is very good. Now, it's a vector, so I could also calculate the magnitude of that velocity vector. V average magnitude would be the square root of Vx squared plus Vy squared plus Vz squared. That's fine too. Okay. If I have a car moving in one dimension, I could just calculate the x velocity. Vx is delta x over delta t. And maybe that's if it's changing speed, then this is the average. If it's not, then this is the speed. See, I did it right there. It's the velocity, the average velocity. Okay, now I'm going to get to this problem right here of a car moving in a circle. But let me tell you what I think of as the speed, because this is important. This is the change in position over the change in time. And that's good. A lot of times people will define speed as this. Distance over time. This is bad. Okay, it really is bad. I mean, in a lot of cases it gives you the same thing. So let's look at the following case. Here is the x-axis. Here's x equals 0. Here's a car moving at a constant velocity, and it gets up here to x equals 10 in 10 seconds. And here t equals 0. So if I calculate the speed, I get distance. Well, it went 10 meters. That's a 10 meter. And it took 10 seconds. So I get 1 meter per second. Yay. Okay. But now, and if I calculate the average velocity, I get delta x over delta t. And so that's going to be 10 minus 0 over 10 minus 0 equals 1. Same thing. So now let's say I start here at x equals 0, but I start over here at x equals negative 3. And at a time of t equals 3 seconds. So I ran the clock for 3 seconds, and then I stopped it, and it goes over here to x equals 7. It's the same situation. It just shifted in both time and space. So if you say speed is distance, well, it went, you could say, some people would say, oh, 7 meters over, and this is t equals 13 seconds, 7 over 13 seconds, and that's wrong. Okay, it's the same situation. Some may say, oh, okay, well, it still went 10 meters. Well, then that's going to be 10 over 13. That's wrong. Okay, but if you use velocity as delta x over delta t, I get 13 minus, I get 7 minus negative 3 over 13 minus 3 is 10 over 10 equals 1 meter per second. So that works. Okay, so if you use distance over time, that's bad. And also, I see this a lot. Distance equals rate times time. I mean, this will give you the right answer sometimes, but it's a terrible idea. I would not use this, not in physics, okay? They like to say even a broken clock is right twice a day. That's why this is right sometimes. It's a terrible way to do it. Okay, let's look at the circular motion problem. Because I want to talk about the difference between average velocity versus instantaneous v. I should say v average versus v instant. So here's my circular track. And I have a car, let's say it's going at 1 meter per second is the magnitude of the velocity. But in this case, it's going in the positive direction. So this is v1 is equal to the vector 0, 1, 0 meter per second. So it has it's not going in the x direction. It's going in the y direction, 1 meter per second. It's not going in the z direction. So over here, and let's say this has a radius of 10 meters. So over here, it's going with the same velocity. v2 magnitude is 1 meter per second. It's driving around at a constant speed. But the velocity 2 is going to actually be 0, -1, 0 meter per second. So the velocity is changing. The magnitude of the velocity is not changing. What if I want to find the speed, distance, over time? Well, how far did it go? It went half a circle. So this is going to be pi times r over the time. Oh, I guess I need the time. Let's say it took a second. I know it's going really fast. So that'd be 1 second. So I get 10 pi. Let's say it's 10 seconds. So I get pi meters per second. That's the speed. Now what if I say it goes all the way around? It should have the same speed. I should have this as 1 meter per second. So it took 10 pi seconds. Got it. Okay. So this is 1 meter per second. It has to agree with that. So if it goes all the way around and gets back to where it was, how far did it go? Well, it went 2 pi r. 2 pi times 10. And how long would that take? Well, it would take 20 pi seconds. So I get 1/2 meter. No, I get 1 meter per second. But what about the average velocity? The average velocity is going to be the change in position over the change in time, but it started and ended at the same spot. And so that's going to be the 0 vector divided by 20 pi seconds is 0 meters per second. So the average velocity as it goes around here is 0. The average vector velocity. The speed, as you want to call it, would be how far it went divided by how long it took. And so those two things are different. I mean, I think we don't always need the speed. You would calculate the magnitude of the velocity that way, but just to know those two things are different. Okay.